Okay, let us continue our discussion about the root finding methods using fixed point iteration method. So this method is another method in the numerical solution in finding the roots of a function. So definition of fixed point iteration. So fixed point iteration is used to determine the fixed point g, which is the solution to the equation of the form g of x equal to x. So as you can see in the illustration of the graph, which illustrates the fixed point iteration method, we have a line here that represents g of x equal to x. So the fixed point iteration method is one of the method that is very basic for finding the root of a nonlinear equation f of x equal to 0. So we'll start the iteration process with a certain value of, let us say, x equal to x0. So and then we substitute it to g of x equal to or say substitute to g of x if g of x equal to or the inequality f x minus g of x less than that of the delta. So where delta is the acceptable error. So if this condition is not satisfied, then g of x becomes the new value of x. Repeating the iteration process until such given condition is satisfied. However, the limitation of this method is at many instances, the iteration diverges from or oscillates between the correct values of root. Hence, the challenge is to rearrange the equation, ensuring convergence and to estimate x sub 0 well. This may require more than one of approximation attempt. So let us consider this graph here, or the illustration of the fixed point iteration method. So in this graph, we have h of x, which is this curve of the function, and also the g of x, represented by the red line. So as you can see, there are point of intersection. The intersection of this point is intersection of the g of x and the h of x. Okay, so we'll converge. We'll find an exact solution that will converge the point of intersection between these two curves here, the h of x and the g of x, until such time that the point of intersection will reach or converges to the root of the function. Okay, so if we consider the function of x equal to, let's say, function of x equal to g of x minus h of x. Now, if we consider that the function of x equal to 0, so we have 0, so you have g of x minus h of x. So therefore we can say that g of x is equal to h of x. Or we can also say that h of x minus g of x is just similar to this previous equation. So the consideration of choosing g of x will be for convergence to the root of the function. So let's have some example for this method to be visualize what is all about. We have here example. Find the roots of the function f of x equal to x cubed plus 5x minus 5 by fixed point iteration method up to 3 decimal places. So we have use initial approximation of x of 0 equal to 0.75. So we have here given a initial approximation of x0 0.75. So basically this method is rearranging the equation or the function. Say function of x equal to x cubed minus x cubed plus 5x minus 5. So therefore, if that is the function, so we will set function of x equal to 0. So therefore, our equation will be x cubed plus 5x minus 5 equal to 0. So we will rearrange the equation so that it will not diverge or oscillate from the root of the function. So our main objective is to this function will converge to its root. So therefore, we can rearrange the equation into this form. Let us say 5x equal to 5 minus x cubed. Okay, as looking back in this function, we can transpose these two variables here, the 5 and the minus x cubed. So you can say we have also value of x which is equal to 5 minus x cubed over 5. So that is our governing equation, or this is our first attempt for the approximation equation that will converge to the root of the function. Okay. Since we have given x sub 0 here, x sub 0 is, we have 0.75. Okay, so we'll substitute that to the equation. So we have initial x1 equal to 5 minus 0.75 cube over 5. So we have value of 0.915625. So again, we will use also this value to get the x2. So for x2, we have x2 5 minus 0.915625 cube over 5. So we have the value of 84,64736. So we'll continue this process by using this function. Say x equal to 5 minus x cubed over 5 as governing to this function. So the process will continue until it converges to the root. Okay, so by repeating this process, we can come up to the convergence of the root. Okay, so after a 10th iteration, or the x10, which I have solved, is 0.86879. So I have compared also the results from x7 until I reach x10, which is merely the same values that I get, which is 0.86879. So meaning they are common with the three decimal places. Okay, so the other roots of this function, since the function is a polynomial degree of 3, which is x cubed plus 5x minus 5. So we have a expecting 3 roots in this function. So the root that we have get is only the real root. So this represents the real root of the function. So the other root will be determined, but initially I have determined it is a complex conjugate roots that I have determined using the MATLAB software. Okay, so the function of x equal to x cubed plus 5x minus 5 can be graphed using MATLAB, which I shown in the next slide in Jamboard. So it can be graphed using MATLAB, and roots of this function can be determined using a graphical approach. So you can see here, for finding a root of function using the graphical approach, must be keep in mind that the root always lies on the x-axis. As you can see, this is the x-axis. Here, this is x-axis, and particularly this is also the y-axis. Okay. Okay, as you can see, this is the x-axis. Also, this is the y-axis. So as you can see, as using the graphical approach, this is particularly the root that we have already defined, which is the value of the root is 0.8688. So this lies on the x-axis. So this root, particularly this root, will be if you substitute in the function of x equal to x cubed plus 5x minus 5, particularly this root function of 0.8688. So that will be resulting, the function will be 0. So meaning if f of x is 0, therefore we already find the root of the function. Okay, and that's the end of this discussion of the fixed point iteration method, and thank you very much. So this is the the con the next video will be representing the Muller's method, which is the root finding solution for the imaginary roots of the function. So again, thank you very much and God bless everyone.